Well, hi everyone, welcome again to my shop, and what I have in front of you is the Heathkit the Heathkit Electronic Projects Kit. It's out of its box. Previously I've had it in its cardboard box, but it's just a little awkward with the lid open. And for what we're about to do now, it doesn't make any sense to have it in the box, because as you can see, all the wires have been removed, and if you've watched my previous videos on this thing, you know I've tried to build two circuits. Actually, one of them was already built when I opened the box. I don't think I did that. If I did, it was years ago. I think I've had these 4, 5, 6 years maybe, just sitting somewhere. So I don't think it was me. I think it was the last person who owned it. In any case, both circuits, or neither circuits rather, worked. So I become quite suspicious of the components. I think what we need to do is go through and check them all. That's a fairly straightforward process, but, well, except for the capacitors. For me, that's a bit of a problem. So let's see what we can do with an ohm meter here. And we'll do the easy things first. How about that? So we'll do this bank of resistors. Okay, so the first one says 1 megohm. And I'll be exploring how good these contacts are at the same time. Let's see. A good idea would be to snap these right in and then see what the reading is. Interesting. So it's supposed to be 1 megohm. I'm going to have to write these down, even though I'm getting them on video. I think it'd be a good idea. Okay, so 1 meg. 1 point is actually 1 point, really 1.4 meg. I can call it that. 1.4 meg. You know what? Doing this might turn out to be the most fun part of the whole thing. It's almost like a... Sorry about that. I just opened a can of pop warning you about the huge sound. Okay, I apologize for that. But man, I was going dry there. Okay, so the 100K is actually 112. Okay. It's not to say when these were brand new they read right on. Of course they didn't. They're plus or minus. And these are all silvers, so not even very good resistors. I suppose if you look at the accuracy band, the percentage band on the resistor, in a kit, that's going to give you a hint as to how good it is. Okay, these numbers are jumping all over the place here. I wonder what's up with that. A loose connection underneath. Yeah, let's take a look at this one underneath. 40, 41. Got my fingers on it right here. Very reliable. A 70 here. Yeah, look at that. But if I try it on the wire, yeah, right on. It's supposed to be a 68. I measured 70 there. I can see a screw head down inside there, which I had not noticed before. That's a screw head that goes with this. So I'm just going to give that a little tweak there. Let's see what happens now. Screw head. Might just be a little corrosion on the metal here. Let me just... yeah, there it is. Quite stable on the screw head, on the screw. So I'm pretty sure if we looked underneath, we'd see the little nut was spinning with it, but I think that's just fine. That's exactly what I want, in fact. Ta-da! Well, not so ta-da. Okay, hey, this is a great time for an experiment. Put this there. Here's the experiment. Contact cleaner. Okay, this might be a little hard on the cardboard, I don't know, but that's a lot of cleaner. I don't know if you can see that on camera, but I soaked it there. Yeah, it's a little better there. Okay. Now, assuming that's the contact that is in trouble, that would be between the spring and the screw head. 70. This one seems more suspicious than the other one. The wire is really touching the nut under there, I think. Sorry, there we go. Some of that could be these probes here. These probes, I think, have become a little bit wonky. I don't know. Maybe not. Okay, onward to the next one. Oh yeah, so 68 was actually 70. I'll write it down here. 68, actually 70. Let's see what happens with this one. $47 is 47. Well, it's supposed to be 22, but it's liking 70. Let's check it out here. 36, 37. So these ones here. Certainly, the wire is certainly under quite well. Screws are, like the nuts are down pretty tight. Let's give them a twist. Two. Sorry, they're sidetracked momentarily. That doesn't take much to sidetrack me sometimes. 22. Hey, look at that. 24. I think we're starting to figure this out. 22K actually comes in at 24. Let's try the 10. I think I probably have the answer for why things haven't been working. It's really the contact issue in here. There's another one. So let's just immediately do that same treatment to it. Which, you know, makes sense, doesn't it? There's nothing spooky about this. I think the wire's bent up here or something. Okay, I got a little twist on it. Got a little bite there. Oops. I should have just done them all, shouldn't I? But actually, I want to do this a little bit, I don't want to say scientifically, you know, with a method so we can make some discoveries here about what's up. Look at that. 11. 11. So the 10K is 11. Now you know what? I'm going back up to this 1 megohm. Let's keep going. I'm going back to the 1 megohm later. That's for sure. That's a little suspicious, isn't it? It's kind of working its way down there. That's really curious. I really got to wonder what was that? What actually just happened? What I'm talking about is the slow decline of the resistance. What exactly would cause that? Well, it stopped at 6.7. Let's just do a little sensitivity check. Ooh. It's gone open. It's kind of odd too. Okay, so I think we'll just give this guy the treatment. Give him the treatment. Trust me, you'll feel like new. Okay, so I don't think I'm really tightening anything there. I think I'm just turning surfaces against the wire. And basically freshening up the contact. And as you know, it's all about bright metal. It's all about bright metal. See, that's bright metal. See that metal? Not so bright, but still pretty bright. Not like that. Because when you see that shine, on metal, what you're actually seeing is photons bouncing off or re-emitted from the electron cloud, which is covering the surface of it. You rub a little off. No, you can't rub those electrons off. But there is a cloud there. You know, when things get corroded, this won't corrode, of course, but when things get corroded and they go dull, like this, they go dull, the corrosion material, if you like, isn't really metal anymore, and the electrons they can't play the same game, and they get trapped kind of inside, underneath the corrosion there. And the corrosion can be just atoms thick, 10 atoms thick, 5 atoms thick. Incredibly thin. Almost like a coating, if you like. And some of those are conductive, like on copper. This happens to be copper. I like that. Copper stable. The copper here, the brown copper oxide, is conductive. Not so on aluminum. Aluminum oxide is not conductive. So, let's carry on now with this guy. Come on. Not a happy camper. Let's give him this the screw here. Oh, that didn't sound very good, did it? Oh, that tightened up. That one tightened up. That's the first one that's actually. This one too tightened up. So I got a tightening and no doubt a little bit of abrasion between the connections. There you go. Supposed to be 4.7, but in fact, oh, it's still jumpy, isn't it? 6.08. We can pretty much call that 5, can't we? Not very impressed with these connections I'm making. I think maybe if you're going to build a circuit, you're going to have to test every wire you connected and prove to yourself that that connection is actually carrying through to the component. I'm certain now this is what, I wired this thing up, but I didn't connect anything to anything. I think that's really the truth of it. Okay, there we go. So that's supposed to be a 1K, but it's actually coming out at 1K. Now let's go back up and look at the high resistance one. I believe I've heard it said that high resistance resistors are the resistors that tend to go high. Take the reading again. That's exactly the same, isn't it? Oop. 1.393. Yeah, that's just absolutely exactly the same. So can't imagine that there's a contact problem here. So consistent work over here. Now, I didn't really expect any of these resistors to be, complete blowouts or anything like that. I would have been quite surprised if any of these were way out. And they certainly aren't. Okay, so next on the list is let's check the relay. Okay, it's probably a 6-volt relay. Dial up 6 volts on the power supply here. Seems pretty good. Check the contacts now. This is up. This one. Maybe this one. Don't think so. Maybe this one. I think so. Maybe this one. I think so. Hey, none of them. That's not good. Okay, how come these guys are zeros? This be the coil connection here. Yeah. So those two are the coil, and these are the switch. So it's just an open-close relay. That's not true. Yeah, the two contacts plus the third one. Which one would that be? Normally open, normally closed. I'm not so sure about the contacts on that. I'm not going to worry about the relay. They would say, look, something like a relay, for sure you're going to have to check it out if you're going to use it. If you're not going to use it, why worry about it? We could do a quick check on the switch down here. Let's put that on. Don't use the switch. Same thing. If you're going to use the switch, you got to clean everything up. Volume control. Copper plated steel. Must be. Or it's not copper at all. Okay, so now it's saying it's 80K. Okay. Okay, 80K. Oh, that's very nice. Very nice. Yeah. We have a winner. Nice and smooth action. How do you like that? I've got the ear. This is the wire to the earphone, and I have the earphone in my ear, which I'm just a little hesitant to touch this other wire, even though it's just my voltmeter. With this thing in my ear, let me just put it behind my ear and listen. I don't hear anything, so I'll stick it in my ear. Yeah, very, very faintly. Yes, I can very, very, very faintly. I can hear it. So we know the headphone is working. Again, I'm not too surprised. Just put these wires in. There we go. Make sure those are in properly. Now, I think we tested this coil earlier, but let's test it again. Again, we're going to have wonky readings here, I bet. Let's see. Okay. Okay. That's good. These are very tight. in there? Huh. I can't sink the screwdriver into the screw. And that's a really thin screwdriver. Here we go. Yeah, we're still reading 0. Okay, now what are we down to here? The lamp, well, again, we'll worry about that if we're going to use it. These 3 transistors. It's going to say in here what kind of transistors they are. I'm sure it will. Look in the parts list. Or did I look before and was kind of let down? 417-35 transistor. Is, yeah, a little more information, please. This is building the actual board here, this part. Notice it has a speaker, and the speaker is missing. The speaker went on to have life beyond the Heathkit. Switch. Transistor. A transistor may be thought of as being like a gate. For example, only one small man opening and closing a gate can allow either many men or few men to pass through. I guess the women are off to the side watching. It depends on how wide he opens the gate. He could also open and close the gate many times and make the men pass through in bunches. I bet you the men would like that. The same thing happens in a transistor. A little bit of electric current at the base of a transistor can control a large amount of electric current passing through the transistor. Okay, now this diagram makes a little more sense. I was really taking a shot at it earlier, but now it makes a little more sense. The 3 main parts of a transistor are emitter, collector, and the base. Whoa, wait a minute. Well, what kind of... I'm not going to say. Come on, they got to say what kind of transistor it is somewhere, don't they? Wow, could it, it's 67, 1967. 1967. Is there any reason to think there weren't silicon transistors in 1967? Of course there were. Well, I guess I'm not going to find it on written on the back here or something. Hey, there's some numbers on the transistors. Aha. Let's take a good close look at that. Let me just change the focus from automatic to manual here. And 3T, 1C, PX, 3T, 3T 1C PX. 3T 1C PX. 3T 1C PX. Okay, I think I got that right. Let me just double check now. Yes. Get the light just right here. 3T. Just 1C, or is that 1C1? It could be 1C1. PX. 1C1. Let's look at the next transistor, see if it's the same one here. 3T, they're clearly 1C PG. 3T 1C PG. That's interesting. What was it? Yeah. Mr. Short-Term Memory. Here he is. Here. Keep my thoughts about me here. 3T 1C. Same as the other, it's just PG. And the last one. It's a little awkward here. Oh, just turn this around. That's a little better. Where's the magic spot here? Okay, I can almost, that's just not quite. Yeah. Don't look into the light. Yes, look into the light. Hey, 2T, 1C, PT. 2T PT. 27? 27. That's not a T, that's a 27. Hang on. No, it's a T. 2T, 1C, PT. Sure, it's a T. 2T, 1C, PT. 2T, 2T. I looked over at the other writing, you know, and I doubt myself. PG? PT. It was PT. Good thing I did doubt myself. PT. Well, that's interesting. I have no clue as to what those really mean. Okay, so the options are pretty simple, though. I mean, it's not there's not too many options. Let me switch the focus back here. The only real options we've got here for these transistors is silicon or germanium. My money's on silicon. I'm not going to say how much money, but so if there's silicon, we expect the junction voltage to be about 0.7 volts. So I'll set my meter to diode so I can test diodes, and we'll treat the transistor like some diodes. Yeah, 200. Screaming germanium loud and clear. That's what I'm hearing. $200. $200 again. 200. That's a very good sign. Fairly good reliability in the connectors. And I'm now going to take my money away from the table because I think they're germanium transistors. It surprises me a little bit. But I think that's what the 200 millivolts are that we kept seeing here. And they all tested the same. I believe they all tested good. And now we're left with these guys. The capacitors. Okay, so first with an ohm meter we can just check for a short. Well, this will be fun. How do I know for sure that there aren't just all kinds of open circuits on the way to it? So we're going to test the leads. We really want to test the component here. So here we go. You know, I'd be floored if we find a short here. Make sure my meter's working. Hey, what's the action with that? 1.6. It's an electrolytic one. Positive, so I got the positive backwards. Let's put it on the right way. Poor thing, for first time he's felt any electricity in years, and it's got to be backwards. Ooh. Apparently he plans to hold on to it. Okay, so this is a phenomenon that I've come to conclude indicates a bad capacitor, and what we're seeing there is a fairly steady, very, very small voltage of 0.07 volts, 0.08, almost 0.1 volts, let's put it that way, 1/10 of a volt, a little under 1/10 of a volt. How does a capacitor end up working like a battery? Well, it does because, for the same reasons a battery works as a battery, which means there has to be some moisture inside the capacitor. And that can set up potential differences between the different metals and the different surfaces of the metals and stuff like that in the capacitor. But it indicates there's moisture in the capacitor. So we've seen two things. One is capacitor has a voltage of its own, not supposed to do that, and reads like a moderate resistor. So that capacitor, I would say if you used it in a circuit, it would probably not help you much. Now, what about the rest of these? They don't appear to have a short. But do they have the capacity they're supposed to have? Now, I could remove each one of them and stick them in my little capacity thing, and that would be a smart thing to do, wouldn't it? But I have another way, an easier way. I want to undo all this stuff. We do need to know how they work from here. And that is by using an audio signal. Okay, so I'm just going to grab an audio signal here. And we're going to need a speaker. I have one right here. It's a bit of a big speaker, but it'll do. And we connect one side of the signal generator output to one of the voice coil leads on the speaker. And the other side, this isn't stupidly simple. The other side, we connect other voice coil, not the other side, the other voice coil, we connect to a clip lead. So I'm left with one signal generator lead and one clip lead coming from the speaker. So we should hear something here. And there we are. Now what we'll do is we'll feed this signal through each of these capacitors. Hear nothing. Hear nothing. Uh-oh. They're getting smaller and smaller, so... Oh no, they're getting bigger and bigger. Bigger and bigger. I heard nothing at all at any moment. I might hear something on this one. Heard nothing. So we're going to take it up in frequency. Back to this one. Now, I'm hoping that's coming across the TV, coming across on the video. The tone. Very high-pitched tone, but it can be heard. I think these capacitors are too small for this approach. It's pretty brutal, don't you think? Yeah. But working there. 0.05. Oh yeah, 0.01, I'm hearing it. I'm hearing it. 0.005. Yeah, I hear it. And 180 micro. That's a mighty small guy. I turned up the volume. Well, I can kind of imagine hearing it. I can certainly hear it there. Okay, so I think I just proved that they're all working. The relative change in the audio strength going through to my speaker seems to me to match the variation in the sizes that are written here. I really have no reason to think these have deteriorated. It would be surprising if they had. So I think the combination of the ohm meter reading and this test, which also proved out the connections quite nicely, says all these capacitors are fine. So I'm kind of convincing myself of that. I think given my knowledge now, which, you know, when I think back on it, it's all kind of obvious, wasn't it? Shouldn't that have been kind of obvious when I looked at the back of this? Shouldn't it have been obvious to me that, hey, it's just going to have a whole whack of connection problems. And this is the thing about the switch. The switch here, you make these connections on the top, and here's how the switch itself has been put in. It's the same springy sort of approach there. That's very interesting, actually, the kind of clip they got. But it's another very light mechanical sort of thing. I mean, it's a far cry from anything being soldered. Hey, this is soldered. That looks terrible. Look at this. Looks like somebody's been at this. Yeah. Well, I think we're ready for another try. Putting together another circuit. I think I have faith now that I can troubleshoot any issues with it and get it working. So, thanks for watching.